In this video, we shall be solving the equation on method of moment. For more on this topic, you need to subscribe to this channel. We are given an equation on negative binomial, and we are asked to find the method of moment, estimators R and P. Solution. We should note that for the method of moment, mu1 is equal to M11. This is the population mean, while this is the sample mean. And this mu1 is equal to the expected value of x. And from the negative binomial expression given, this is our expectation, while this is the variance. So the expected value of x is equal to r 1 minus p all over p given. Also, we take this as our equation 1. Also, the sample mean is equal to 1 all over n summation of xi. This is the sample mean. We take this as our equation 2. The solution for the method of moment is when you combine these two things together. That is when you combine the population mean and the sample mean. So combining equation 1 and equation 2, we get r 1 minus p all over p to be equal to this, which is 1 all over n summation of xi. Of course, we know that 1 minus p all over p is equal to, this is mean, which is mean. So it then means that we cross multiply. When we cross multiply, we'll have p multiplied by this, then r multiplied by 1 minus p. We have that p multiplied by the sample mean is equal to r 1 minus p. Let's take this as our equation start. Also, for the method of moment, the second moment, we have this. This is the population mean, while this is the sample mean. It then means that this population mean is equal to the expected value of x squared, while this is the sample mean, which is 1 all over n summation of xi squared. So this is the sample mean. We take this as our equation 3 and this as our equation 4. We come over here. Of course, the expected value of x squared, we cannot get it easily. So we recall that the variance of x is equal to the expected value of x squared minus the expected value of x all squared. So we make this the subject of formula. If we make the expected value of x squared the subject formula, we have variance of x plus the expected value of x all squared. So what is our variance of x? Our variance of x is given to us as this. So we have the expected value of x squared to be equal to the variance of x, which is r multiplied by 1 minus p all over p squared plus the expected value of s, which is r 1 minus p all over p all squared. It then means that if we open this bracket, we get r 1 minus p all over p squared plus, say, r 1 minus p all squared all over p squared. So the next thing to do is to combine 3 and 4. Equation 3 and equation 4. Combining equation 3 and equation 4, we get the population mean to be this, which is the whole of this, r 1 minus p all over p squared plus r 1 minus p all squared all over p squared to be equal to 1 all over n summation of x I squared. So this is what we get. The next thing to do, since they have the same denominator, we take one of each. So we can write it as r 1 minus p plus r 1 minus p all squared all over p squared to be equal to 1 all over n summation of x I squared. Then we'll recall that from equation star, because we have something there. We have that p x bar is equal to r 1 minus p. So we substitute this equation star. Anywhere we see r multiplied by 1 minus p, we substitute it into this. It then means that the whole of this will now become p multiplied by the mean. So we come over to this other side. We come over to this other side. So we are substituting. Anywhere we see r1 minus p, we put px. So it then means that we have here px bar plus px bar all squared all over p squared to be equal to 1 all over n summation of x I squared. So we can cancel here. Something can come out here. We can have px bar plus p squared, if we open the brackets, x bar all over p squared to be equal to 1 all over n summation of xi squared. So p can come out here to give us p multiplied by this p x bar squared all over p squared is equal to 1 all over n summation of xi squared. Of course, this will cancel this. So we'll be left with just say x bar, we can put it this way, p plus p x bar squared all over p to be equal to 1 all over n summation of xi squared. So this is what we get. We'll still move over to this place because we are asked to estimate, to find the method of moment for r and p estimators. We come over to this side. We come over to this place. For more on this topic, you need to subscribe to this channel. So we come over here, if you watch, P can cancel P. So we'll be left with just X bar all over P plus X bar squared to be equal to 1 all over N summation of Xi squared. Of course, this can go over to this place. So we have X bar all over P to be equal to 1 all over N summation of Xi squared minus X bar squared. So 1 all over P can be equal to 1 all over N summation of Xi. We can open this to put it this way, X bar all squared all over X bar. It then means that our P estimate is equal to X bar all over 1 all over N summation of Xi X bar all squared. So we have succeeded in estimating P. So this is P estimate for method of moment for the negative binomial. This is what we get. The next thing is to estimate R. To estimate R. For we to estimate R, we recall, to estimate R, we recall that we once said P X bar is equal to, that means, recall from equation star. Recall, to estimate R, we recall from equation star that P X bar is equal to R 1 minus P. That is what we got. We'll move over to this side. Move over to this side. We are trying to estimate R. For more on this, you need to subscribe to this channel. So since we have this, we have that P X bar is equal to R. We can open that bracket minus RP. So it then means that R is equal to P X bar plus RP. R is equal to P X bar plus R. We can make P the subject. P to be equal to R all over X bar plus R, which is the same thing as, we can put it this form, in this form, X bar plus R all over R. For this to cancel this, to give us 1, we now have P to be equal to R all over X bar plus 1, which is the same thing as R plus X bar all over X bar if we generalize it. So we have our P to be equal to R plus X bar all over X bar. Then from our P estimate, anywhere we see P, we put the whole of this inside. So if we say this is our equation hash, we now say from equation hash, we now have R plus X bar all over X bar to be equal to x bar all over 1 all over n summation of xi minus x bar all squared. So that is it. So this will come over here, while this will go over to the other side. So that is how to estimate for R. But how do we make R the estimate? Is what we are about to do. We still come over to this side. We come over to this side this time. So this will go here, while this will go over to the other side. So if this goes over to this side, we'll have our arrow by cross multiplying, so that we understand what we are doing. If we cross multiply, we'll have our arrow estimate to be equal to x bar squared all over you have our x bar squared all over 1 all over n summation of xi minus x bar all squared minus this will come over to this side, then we have x bar. So once we cross multiply, we have something like this. Then if this is adding this, as it's going over to this side, that side, we get minus x bar. So we have simply gotten our P estimate and R estimate for the method of moment estimation and for the negative binomial. So this is how to obtain P and R for the negative binomial. For more on this topic, you need to subscribe to this channel for you to get more on this.